All right. Can you hear me okay?
Yes, I
Yeah?
hear you just fine.
All right. And can you see my screen?
I see your screen. Looks great.
Perfect. Okay, let's get started. So today we're going to talk about the Studio Orchestrator platform that we use at Netflix to power a lot of production workflows. When I say productions, I mean producing content kind of thing. My name is Joe Thomas. I'm from the digital productions engineering team, which is actually a sub team within the larger content engineering team at Netflix. You know, the content engineering team does everything pretty much to do with the content side. You know, they deal with everything from the pre-green light of a show all the way till the time it goes live on the service. Our team actually works on the coolest part of the entire workflow. It's where the production happens. You know, where the artists come together and put together the kind of movies and TV shows that we love to watch. So that's what we do. Before we get started, a couple of quick, questions for you folks to think about. How many hours of content did Netflix produce or put out there in 2019? This is a few years ago, but take a guess. I'll give you everybody maybe like 10 seconds to respond to that. Okay, next question. On an average, you know, when people are shooting a movie, let's say, you know, using a camera, how many hours of footage gets shot for every hour of content that you see on the screen?
This is an interesting one.
Do we have a good set of answers, Doug?
So yeah, I'll have to go back. I did these as separate polls, but on this one, the majority of people are saying between 10 and 50. So 46% came out at 10 and 50. We've got 8%, 5 and 10, 46% 10 and 50, 33% 50 and 100, and 13% guessed 100 to 500.
Yeah, so the answer really is the 100 to 500 range, you know. So it's basically, this is to give you a perspective of the amount of footage, the amount of image data that really gets produced in a show, you know. So given the number of hours of content Netflix puts out there, times the amount of, you know, hours of footage, kind of gives you a perspective of, you know, the amount of actual image data that gets produced. And it's somewhat naive to simply multiply those numbers because there's a lot of variance in the type of content. Not everything is produced by Netflix, but still it kind of gives everybody a perspective of the amount of data that actually gets produced. And that's something that'll kind of play into what we're going to talk about the rest of this talk. So in the digital productions engineering team, we work with a lot of different phases or different types of production, entities. You know, on this live action, which is the case where folks are shooting with a camera with live actors. Animation, which a lot of us are familiar with, which is basically drawing, CGI, those kind of stuff, and VFX, which is the visual effects kind of thing. So these different phases of production have very different types of workflow, very different types of processes, and they produce a wide variety of different types of assets. But that said, they still do have a lot of commonality. You know, as we saw, most of them produce a very large amount of image data, and it's very imperative, as you can imagine, that these are stored without getting lost, and they need to be tagged and indexed so you can go find them at a later time. For instance, if you had a scene where there were several takes and there was one take that the director liked, you know, you need to be able to go and find that at the right time. Ultimately, you know, that's probably the take that has to make it all the way to the end of the final produced content. Then there's security and encryption, so we don't want any of the content to leak or be accessible to anybody without, without proper authorization. It is, a lot of money gets spent making productions, and it is very important for the studios to guard it and make sure that there's no leaks happening. And also, most shows tend to have, artists around the world. There are, the production, the shooting may happen in one location, the VFX may happen somewhere else, the editing may happen elsewhere, and so on. So there is a lot of, distributed users, and generally a lot of data needs to get sent back and forth. Then there is this idea of transcoding. What comes out of the media of the camera is usually in a rather raw format. It's basically what's captured on like CCD camera. So they are lossless, and they tend to be very high, large in size, generally speaking. And they need to be converted to various different formats that are used by downstream processes. For example, VFX may have it in a different form. An editorial might want it in a different form. And ultimately, you need to put it all together and make it visible. Make it available in a form that can be consumed by folks like us who are just streaming on devices. And the other thing that's involved here is also things like reviews. So if you a director might want to review key pieces of the show and approvals and so on. So there are a lot of things that are common among all these different verticals, if I may call it that, within the content production ecosystem. However, though, when you think of that, you may think, oh, okay, the cloud is probably a very obvious choice, but traditionally productions tend to be very very on-prem focused. That's partly because if you think of it, a lot of the content creation tools have traditionally worked on local systems, because they need to have very quick response to the user, and you don't want to be you don't want to have that lag in the user experience. So generally, a lot of productions have traditionally gone for a very local on-prem kind of compute and storage. And to make matters worse, productions generally come up for the duration of producing a content, and they kind of disband and go away. So they don't necessarily invest a lot in making things fully automated. They just usually cobble things together for the duration of the production and move on. And an interesting tidbit there is, in the early days of COVID, back in February of 2020, people weren't probably even aware of this thing called COVID. I happened to be talking to a VFX vendor in Mumbai, and they were one of the first to be impacted by COVID, because they weren't able to get all the disk drives that they typically use to store and transport these image data between different vendors. So there's a huge reliance today on sending actual hard disks between vendors and so on. But if you think of it in a Netflix scale, this is probably not going to work. If you have this much amount of content that is being produced, we need to have better technologies. We probably need to adopt something like that's closer to the cloud, and that's where the Studio Orchestrator platform comes in, which is what we'll talk about the rest of this stuff. So in simple words, the Studio Orchestrator platform, it allows developers to basically author pipelines, and pipelines is, think of it as a production world terminology, and pipelines are essentially process flows that are used in the content production space, where media gets moved around from different parties, transcodes happen, things like that. So that's so pipelines are basically written to automate these kind of production flows. They're not always fully automatic. Sometimes there's a lot of manual intervention. People may do things traditionally, at least, which are manual. And in our world, in the Studio Orchestrator world, we try to automate most of it. And here's where we actually leverage Conductor work. So if you Under the covers, a complex production pipeline may be composed of several conductor workflows. And the pipelines typically would produce a large number of artifacts or assets, as we call it. And these assets are then, made available to perhaps other pipelines. In some cases, these need to be viewed on user interfaces for, folks that are working on the production and so on. And in many cases, yeah, they're used in other downstream processes or other pipelines along the way. And these pipelines, they are usually started or are interacted by users or automated processes. For example, somebody adding or uploading a new piece of footage might automatically kick off some pipelines that may do some processing. That's a high level of what the orchestrator platform is trying to do. If you dive a little bit and look behind the scenes a bit, the Studio Orchestrator pipelines essentially have these components in there. One is the process flow, which is where Conductor fits in. We'll talk about it a little bit later. Then there's a state management. So depending on the complexity of the pipeline, it may go through different states, and different things are allowed to happen in different states. So there is, this entire state management around what actions are possible at what stage of a pipeline, and who can do what at what stage of the pipeline. Then there is all the resources that I talked about, the storage of the things that the pipeline may produce along the way, and how they get stored, and for easier retrieval later, and so on. And since pipelines work in a world where there are many async things happening, they need to be aware of these kind of events and be able to react to how these events get produced along the way. And ultimately, these need to be often surfaced to other users in the production. Not maybe the pipeline developers, but people on the production who are looking at the status of certain things, or how things are progressing, or people who are using the outputs of pipeline. So they often need to be able to go look in a UI, and look at where things are, whether you can consume certain things and so on. So there is a bunch of UI widgets and a lot of GraphQL REST endpoints that we have to enable that. So like I said, the Studio Orchestrator platform is really a tool for developers, developers on a production. It is not entirely for them, though. There are a lot of engineering teams within Netflix, within the digital productions engineering team that also use it. But we focus a lot on the production use cases, because that's where we see a wide variety of different types of users who probably not use the Netflix cloud, or not really close to the Netflix cloud as maybe the engineering team might. So it's very important that we lower the barrier to entry to come and start using the features of the Netflix cloud ecosystem. For example, we already have things like transporting services, asset management systems, where you can tag and store assets and so on. But we want it to be very easy for our developers on productions to be able to use it. And productions also tend to move very fast. They don't have a lot of time. Because once you greenlight a production, most studios want the content to be on the service pretty quickly, and this is productions being so complex. There is usually very little leeway for any lost time. So it's important that these developers, these pipeline developers, are able to quickly iterate, quickly build and test and deploy things without learning a lot of new things along the way. So as you can see, reusability is probably something we need to focus on. Also, these need to be reliable. We don't want, like I said, productions being very time sensitive. We don't want downtime or failures that are hard to diagnose or fix. So it's very important that the pipelines, when they fail, it's relatively easy to go there, figure it out, fix, and move on. And like I was referring to earlier, there's a very wide variety of developer types. You know, a lot of folks in the pipelines world and the production pipelines world, you know, come from a Python language background. That's because a lot of the tools, you know, a lot of the content creation tools, you know, are basically use Python. You know, things like Nuke, Maya, things like that. So we need to make sure that, you know, there is no learning curve, that it's very language agnostic. You know, we want to be able to work with a wide variety of languages, and of course, you know, internally within Netflix, you know, a lot of the engineers prefer the Java, Kotlin style language. The other thing is, you know, the productions are seldom just running in the Netflix ecosystem. You know, it often connects a very large number of vendors, partners, and so on. So we need to be able to orchestrate across these differing entities. And also these vendors, some of them are very sophisticated, some of them not so much. So we need to be able to account for all this kind of variances in the Orchestrator platform. And that's where, you know, like I said, Conductor comes in. Conductor is a key tool within the Studio Orchestrator platform. The process piece is entirely done with Conductor today. The way we did it is, you know, since we had to focus a lot on reusability, we took the path of building reusable tasks. So the idea is that, you know, we won't. Oftentimes, you know, people may write a task that works in one case and one case alone. But instead, we said, okay, let's break it down, make them into unit tasks that do a unit function. When I say unit function, it's probably you know, the granularity is something that's subjective, you know, but what we're trying to say is, you know, something that's large enough to be a single business function, but not too broad, not doing too many things, you know. So we call these the standard task library. So these tasks are these unit tasks, you know, that can be easily plugged together, assembled to make what you're trying to achieve. So the idea is to lean into assembly, you know, to use these unit tasks so you get high leverage. And with these tasks, you know, we've also focused on strongly typed inputs and outputs. You know, it's very important that, you know, as a pipeline developer who's coming in and trying to use a standard task, to be able to know, okay, what are the things I need to give it? What are the inputs? What does it produce? And that's where the composability comes in. It's like a function, right? When you write a function, you know how to string them together because you know exactly what inputs and outputs are. So, you know, the whole idea of, you know, reusability, and it comes from this notion, the composable typed inputs. So you should be able to assemble them together, and you know, that should also open up a lot of tooling and in fact type checking along the way. So, you know, I have a little graphic on the side here. You know, you'll see a lot of tasks that are prefixed with a name STL, and these are all tasks that we reuse across many different pipelines or even Conductor workflows. You know, for example, there's a request.assign, you know, so or STL.await render farm task. You know, this is like, you know, when you send a task out to like a transcoding system, and then we have standard ways of sending it there, waiting for it to come back, and so on. So that's kind of a flavor of what an STL looks like. As an example, I think I missed a slide there. Okay. As an example of a pipeline, I'll quickly talk through a plate ingest pipeline. A plate is a notion in the VFX world, and it's essentially, you know, let's say if you're doing an effect on a shot, so you basically go to the camera footage, you'll take that section of the footage that you want to apply the effect on, and that thing is essentially called the plate. And these things are usually stored as individual image files. And so in the plate ingest, what it's trying to do is it's basically you know, getting the plates, getting it ready ultimately for a VFX artist to work on. You know, that's the whole purpose of this pipeline. It might sound very simple, but it's actually quite complex behind. So this pipeline gets kicked off when plate upload happens. So it's basically we are waiting on our on some of the events to come through, saying that okay, something has been uploaded to this particular folder in a cloud storage, and once that's done, the pipeline gets triggered. And the things that may happen are things like, okay, the plates may come in a certain format. We may need to relay out it in a way that's consumable for the internal artists that actually are working on the VFX, doing the actual effect. And oftentimes in this particular case, we need to do some color transforms. So that is basically the space in which the color space in which the image files may be given is not necessarily the color space in which the artist works. So we have to run some custom color transform jobs to do it, and that's done through these custom color transform nuke scripts that we actually generate on the fly, which we then run on a render node. When I say render, it's basically that color transform function. And then we need to create records for to track these in the system called ShotGrid, which is what's used by the VFX artists to know what's coming and track progress there. And we also need to like I said, these plates are essentially individual files. They're not playable, so we need to also generate playable videos, which can be and many different flavors of that. Things that are 4K, which are not necessarily visible or browse or streamable on a browser, and also some encodes that are streamable to the browser. So all the people that are involved in this whole process can have an encode of their expectation, essentially. And ultimately, these need to be copied over to, like in this particular case, an NFS mount, an NFS disk, which is not cloud storage, not necessarily the same kind of cloud storage. And this is where the artist can finally access all these these files that they can start work on. And finally, we have to make upload more things to ShotGrid, catalog everything in our asset management system, so we have a good tracking of what is coming and so on. So all these kind of things, this is a process part of the pipeline, and these are all powered by Conductor workflows. And I have little snippets from my workflow. It's pretty large. It has probably, this entire pipeline would have several hundred tasks. And it's actually composed of several sub-pipelines too. And so I just want to give a quick sample of some of the tasks that are involved in this entire process. So that's just to give a flavor of what some of the pipelines do. There are some that are way more complex. Some of them are much simpler, but wide variety of these kind of pipelines. A few stats. We have about a little over 250 STLs, standard tasks that people can string together to create pipelines. We have about a little over 100, around 110 actively used pipeline types today. And every month we execute about 500K. This is actually as of last month, pipeline executions every month. And each pipeline is typically, on average, about 5 Conductor workflows. So you can imagine, number of Conductor workflows easily runs in the millions per month for us. Now, to talk about how we go about making this all easy for pipeline developers. So we've been developing a lot of tooling to make it easier for our pipeline authors to do their work. So our goal ultimately is to make it super easy for these pipeline developers to come in and piece things together, discover these STLs, because oftentimes they don't, pipeline developers might not know right off the bat what's available. So they need to be discoverable, and they need to be able to string them together pretty quickly to make something get something going. So we've been working a lot of, and this is something that we are actively working on. There's an authoring tool, which among, what we are seeing here is the process side of it, but there's also, like I said, the the states that this thing, that the pipeline might go through, all the resources that get produced, all those kind of things can be, expressed in using this authoring tool. We also have other tools which are used, like these are also kind of targeted at developers. It's pipeline developers or even support folks to kind of take a look at, a little bit under the covers of what a pipeline is doing, perhaps. And here what I've shown is really a subset of a rather large pipeline. In this particular pipeline, there are probably about 1,000 different tasks. This is one of the larger ones. And each green box or each little box you see here is actually a pipeline, which is in turn composed of several Conductor workflows. So we have a few tools that are out there to aid our developers, in building and deploying these pipelines. And this is a quick view of what end users, not the pipeline developers, but people who are on the production who might actually be working with these kind of pipelines. So there are UIs that can be built, which lets those folks kind of look at pipelines. This is essentially what you're seeing here is essentially a list of a certain type of pipeline. In this particular case, it's like a VFX delivery pipeline. It may be a kind of pipeline that actually may grab footage, chunk out certain plates from it, and deliver to a vendor kind of thing. And this is a detailed view, and I can click into it, and you can see, what you're seeing here is really the different resources that are associated with the pipeline. This particular case, these are really what are called assets, basically VFX plate assets. And these are consumed by real end users on the production. So that's a quick look at the pipeline orchestrator, and I just want to share a few of the productions that you may love that are actually built with Studio Orchestrator. We have Chicken Run, which is due for release sometime in 2023. This is for the lovers of Chicken Run. The Chicken Run 1 came out, I think, way back in 2000. Loved by a lot of different folks, stop motion kind of thing. So we are working very actively with this production to apply pipelines. There's a lot of pipeline goodness being used in this production. And Money Heist / La Casa de Papel season 5, used a lot of live action kind of pipelines. And we got a lot of rave reviews from the production for how much time they were able to solve. Basically, in this whole idea of lifting away from a local storage onto cloud storage, and the kind of power that it actually unleashed for the production. And there are several more. These are just a few of the big names that sort of came up, but there are many, many more. And these are probably names of shows that you might not even have heard of. But what I want to highlight really is the fact that a lot of these shows are produced in many different regions, just to show that we're getting a lot of regional adoption across other different regions, different languages, and so on. So several productions currently using Studio Orchestrator. And while these are still early days, not all productions use them, use the Orchestrator, but we are working to increase adoption there as well. So we are starting slow, trying to ramp up. So that's it from me. So any questions?
Well, that was awesome. We do have one question up, or there's some coming in right now, but the first question is in the chat, and it says, what does an individual STL look like in terms of Java or Kotlin code?
So
so we have, in the standard Conductor way, you typically, if you write the Java way, you would, implement, extend the worker class. But what we did was we kind of wrapped it a little bit in such a way that, we get strong type checking and strong optionality checking along in the inputs and outputs. And we try to keep the worker itself rather slim and write the most of the heavy lift code in the service layer. So we kind of think of STL as analogous to writing a REST endpoint, for instance, right? The only thing that we try to guard against is we don't want them to be too micro kind of functions. We want it to be somewhat coarse function, because if they're too small in the kind of task they do, then your workflow is going to explode the number of tasks and it'll become unmanageable. So we wanted to find that sweet spot. Of course, it's a little bit of a it's subjective, really. So you need to find that sweet spot where it's not too coarse that you limit reusability, but it's not too fine that you need too many of those tasks. So without really showing you the code for one of these tasks, those are some things I can talk about, what a task looks like. And like I said, we try to keep the most of the code in like service layers, and think of the worker class similar to on the same lines as you write like controller tasks for controller classes for REST endpoints kind of thing. Does that answer the question?
We'll give Prem a second to reply. Yes, thank you. That's awesome.
Yeah, and like I said, the whole point was, we wanted to lean into assembly, so that we can string them together, focus on reusability.
That makes a lot of sense. Like just in my experience, everybody wants to have reusable code, but if you generate something that's too complex, they'll be like, yeah, but I only need this part, that part, and this part, right. And they need to rebuild the middle. So if you just build, if you build A, B, C, and D, and they use A, B, and D and build their own C, like you just save them a bunch of time. Exactly. And then hopefully, you'll have C and C1, and you have a bunch of new STLs for that third step in your pipeline that people can reuse.
True, exactly. And it's not always obvious, way to draw that line, so sometimes, you learn as you go, but, as long as you keep that North Star of, reusability without compromising on complexity is really where you want to, find that sweet spot. There's also a question in the Q&A box from Aaron. Do you want to read it out?
Yeah, sure. Aaron asks, who's building the pipelines? Is it Netflix engineers or is it the developers at the VFX studios?
The answer is both. So we have, people, what are called TDs, they call technical directors. These are folks that are technical people embedded in a production. We want them to write a lot of these workflows. But on the other hand, Netflix engineers write a very big chunk of these pipelines as well, because there are some of the heavy lift backend kind of things that we end up writing, and production specific ones we want, the TDs on the shows, on the VFX groups to write. So, it could be VFX studios, it could also be, other productions like animation, they may have their own kind of TDs doing something. So we want them to also start writing along. We have some adoption there, and that's really our focus for this coming few months.
Do you have like like in some terms you'd call it a marketplace, but like a repository of the different STLs that the TDs have built? So, if Chicken Run has built a TD, maybe it can be used by a different studio.
Absolutely. So we have a way for, STLs today as it stands, a majority have been written by Netflix engineers, but we are totally, we are in a place where we can accept, STLs written by others as well. So there is a way for individual STL developers to publish these STLs, and then they become discoverable. And we are working on some controls, because in some cases, some shows may choose not to publish their STLs too broadly. They may want to say that, okay, this is only available within a show and so on. But yes, the answer to your question is yes. It is possible for STL developers to be in any of these different entities and any of these different teams, and they can be discovered and used by other pipeline developers.
That's super cool, because I can only imagine that any production, if you're creating a new STL, like you might be reinventing the wheel. And if you can snag something from another production that's already gone through these pains.
We hear that all the time. Yeah, it's like, isn't it already there kind of thing, right? Why am I doing that? And they say, yeah, it is there. So
Right.
And that is, of course, the key to reusability, and also the ability to discover these, right? So, when you have 200 already, you're hitting a higher limit. So you want to be able to, for people to rather easily look for these.
So that's the next issue, I guess, is becoming a victim of your success and having so many STLs that how do I find the right one for what I need? Because if you're running at a high velocity, you don't want to read a bunch of readmes or whatever the way you find it. You want to just get a quick synopsis to find those files.
Yeah. And I'm no big fan of reading huge set of documents. So we want it to be concise and precise so that, so people, and also the naming, right? Ideally, the name has to be pretty nicely named so that, at least you narrow in pretty nicely. And then maybe from a few, you have to maybe dive a little bit deeper, but it should be, it's very important, like you say, like people say, the hardest problems in computing is naming, right? So, we want naming that's easily understandable, discoverable, and so on. Yes.
All right, so we have a couple more questions in the chat. Have studios applied this to test screenings and to post-analysis? Are they using it for anything after they create their projects?
Not that I know of. I would say no at this point. Currently, it's mostly for the true production process, until the final movie gets produced. That's where the focus has been so far at this point.
And his second
Not
part
to say
is,
that, if the use cases come up, we'd be happy to dive into it.
That'd be super cool, because I assume that a lot of the analytics that people were doing, Murthy replied, the screening pipelines is using it post-analysis. Oh no, our studio's using it outside of Netflix productions, and it looks like the MEFYC transcoding is being used outside of Netflix productions, if I'm reading the Q&A right. This is fabulous. Like, I just, one of those questions, I think as developers, we often want to know, like, how did they make this? Like, what's going on? I don't know if it's the right term to say, but how's the sausage made, right? Like, everybody kind of wonders, like, there's a lot of video going on, and like, how do you do this efficiently? And it's really neat to see that one of the tools behind the scenes is Conductor, because, well, we work on it day to day. And so it's fun to see that, if my kids ask me, hey, Dad, what do people use Conductor for? I said, hey, you remember that show we watched or the movie we watched last weekend? They're like, oh, okay. Like it's there's actually an application that makes sense to them. So that's always a good thing to be able to present.
Yeah, make sure you watch Chicken Run, and heavily leveraging Conductor, right?
Very cool.
And it's coming out 2023,
awesome.
And several others, so maybe something that you watched on Netflix the other day was built using Conductor. So
that's awesome. That is super cool. Well, the questions have slowed down a little bit, but I want to thank you so very much for giving this presentation. If you missed anything, we had a couple of people say they had some Zoom issues. This is being recorded, so I will create a video of this and pop it up on YouTube in the next day or so. I was talking to Jose earlier that I just moved out into the wilds of Maine, and my uplink is really, really slow until I get that satellite dish put on the roof of my house. So I will get it up, but it may just take a little longer than normal because my DSL has 2 megabits up, and that's really
thank you again. Big thanks goes to Doug for making this a rather smooth show. Thank you, Doug. And also thanks to all the Orchis folks for letting me come and talk to you all, and for all the folks who tuned in, maybe evening for some, morning or late night. So thank you all for showing up, and all big thanks also to my teammates in the DPE team, whose work I'm here to represent. So
awesome.
Thank you to everyone.